Hello, this is Nishchita. I'm from NYU Poly and I'm recording this video as a part of my homework for probability and stochastic processes. Today I'm solving question 2 from homework 2. So the question says f of x is given as a into e to the power of minus 2 into delta of x for x is equal to 0, e to the power of minus 1 into e to the power of x plus e to the power of minus x for x between 0 and 1 and 0 otherwise. So the first sub question says find a so that f of x is a valid density function. So in order for any function to be a valid density function, the overall integration of the given function should be equal to 1. So we can take 1 as equal to integration of 0 to infinity f of x dx, which comes to for x is equal to 0, we can take it as a into e to the power of minus 2 integration of x is equal to 0 delta of x plus integration of 0 to 1 e to the power of minus 1 into e to the power of x plus e to the power of minus x dx. So you can if we integrate delta x, we get 1, and similarly we can take out e to the power of minus 1 and integrate e to the power of x plus e to the power of minus x. The integration of e to the power of x with respect to dx will be e to the power of x itself. So for e to the power of minus x, we can take x is equal to minus y and then replace dx with minus dy and continue the integration in a basic way. So in the end we'll end up with if you calculate all of this and then cancel the terms on e to the power of minus 1 and minus e to the power of minus 1. So we'll end up with a into e to the power of minus 2 minus e to the power of minus 2 as 0. So if you take e to the power of minus 2 as a common common term, you'll end up with e to the power of minus 2 into a minus 1 is equal to 0, which will give you a is equal to 1. So the second part of the question says sketch f of x fx of x. So at x is equal to 0, we can get that fx of x will be a into e to the power of minus 2 into delta of x. Because we have already calculated the value of a, we can take it as 1. So at x is equal to 0, it becomes e to the power of minus 2, since delta of x is only 1 at x is equal to 0. For 0 to 1, we can take f of x is equal to e to the power of minus 1 into e to the power of x plus e to the power of minus x. So if you substitute x is equal to 0, you'll get e to the power, f of x will be 2 into e to the power of minus 1. So again, for x is equal to 1, if you calculate f of x, it'll come up to 1 plus 1 by e square. So for x greater than 1, it will be 0. So if you sketch that on a Cartesian coordinate basis, you'll end up with a graph looking like this. For 0, it will be e to the power of minus 1. And then it goes up to 2 into e to the power of minus 1, and then we have an increasing function till 1 plus e to the power of minus 2 at x is equal to 1. So the third sub question of the question 2 says write f of x in form of step function. So you can take f of x, we have already sketched f of x, so we can directly write it as fx of x will be e to the power of minus 2 into du of x by dx plus e to the power of minus 1 into e to the power of x plus e to the power of minus x into u of x minus 1, which will represent the part where 0 to 1. So the fourth sub question is to find capital fx of x in analytical form. So we know that capital fx of x will be integration of minus infinity to x small f of x into dx. So for different values of x, we can we get these different values of fx of x. So for x is equal to 0, you'll get fx of x is e to the power of minus x delta of x, and between 0 to 1, you'll get it as e to the power of minus 2 plus 0 to x e to the power of minus 1 into e to the power of x plus e to the power of minus x dx. So if you integrate that separately, so you'll end up with fx of x will be e to the power of minus 2 plus 0 from between 0 to 1, it will be e to the power of minus 2 plus e to the power of minus 1 into e to the power of x plus e to the power of minus x dx. So you can write that as fx of x will be e to the power of minus 2 at x is equal to 0, e to the power of minus 2 plus e to the power of minus 1 into e to the power of x plus e to the power of minus x in between 0 and 1, and 1 for the value of x greater than 1. So we can sketch the same fx of x as for 0 it will be it starts with e to the power of minus 2, And if you take various values between 0.1 to 0.9 or anywhere between 0 to 1, you can see that this function is an increasing function. So from e to the power of minus 2, the function keeps increasing till 1, and after 1 the value will be a continuous value, which is it stays continuous at 1. So this gives you fx of capital X.